along with fascinating facts about its outer layers that continue to challenge our understanding of physics. Did you know that, despite studying the sun for centuries, we still cannot truly see what happens in its depths? The sun's interior remains one of science's greatest mysteries. But how is it possible to understand what's inside a massive star like the sun if we can't simply look into it? Today, we'll uncover how scientists manage to study the sun's interior, comprehend its extreme conditions, and reveal what really happens in the deepest layers of this enormous ball of plasma. Why can't we see inside the sun? First, we need to understand why it's impossible to simply look inside the sun. The sun is composed of gas and plasma, which makes it incredibly challenging for any current technology to penetrate its layers and observe what's happening within. On top of that, the conditions inside the sun are extraordinarily intense, with temperatures reaching millions of degrees Celsius and pressures beyond imagination. These extreme conditions make any attempt at direct observation not only difficult but virtually impossible. Even though we can't directly see inside the sun, scientists have discovered that it is composed of several layers, each playing a specific role in its structure and function. The sun is divided into 6 main layers, which can be grouped into outer and inner layers. The 3 outer layers are the corona, the chromosphere, and the photosphere. These are the layers we can observe, in a way, through telescopes and space probes. The 3 inner layers are the convective zone, the radiative zone, and the core. These layers lie much deeper and are where the energy and heat production takes place. Although we cannot directly look inside the sun, scientists have developed innovative methods to understand what's happening in the heart of this giant star. Each new discovery brings us closer to uncovering the secrets of the sun and how it sustains life on Earth. The sun's inner layers are the most critical for the star's functioning, as they are responsible for producing the immense energy that reaches us. Now, we arrive at the center of the sun, its core. The core is where all the sun's energy is generated through a process called nuclear fusion. This is the heart of the star, where energy is created and begins its journey to the surface, powering the entire solar system. In the sun's core, hydrogen atoms collide with such immense force that they fuse to form helium. This process, known as nuclear fusion, releases an enormous amount of energy in the form of radiation and subatomic particles. Conditions in the sun's core are extreme. Temperatures reach about 15 million degrees Celsius, and the pressure is millions of times greater than Earth's atmospheric pressure. The energy released in the sun's core is so intense that, in just 1 second, it generates more energy than 1 billion atomic bombs. This energy travels slowly toward the sun's outer layers, passing through the radiative zone and the convective zone before finally reaching the photosphere and radiating into space. Summary of the sun's layers. Outer layers. Corona, the hottest layer outside the sun, visible only during eclipses or with X-ray technology. Chromosphere, the forest of flames, marked by spicules and its red hue. Photosphere, known as the surface of the sun, it's the source of the sunlight we see on Earth. Inner layers. Convective zone, the boiling pot that transfers heat to the outer layers. Radiative zone, the region where photons take thousands of years to move. Core, the nuclear heart, generating energy by fusing hydrogen into helium. The power of the core. Imagine the power of 1 billion atomic bombs being released in just 1 second. The sun's core is not only incredibly hot, but also unimaginably intense and violent. Although the sun is one among billions of stars, it's the only one we know of that sustains life around it. It connects us to the universe and the cosmic cycle of star birth and death. The sunlight that warms us today began its journey approximately 100,000 years ago in the core. Which layer of the sun did you find most fascinating? The corona, the core, or another one? Let us know in the comments. Remember that the sun is not just a star, It's the driving force behind life on Earth. Its energy powers the climate, the seasons, and even photosynthesis, which sustains the food chain. We've explored each of the sun's 6 layers, from the corona all the way down to the core. We've learned how each layer plays a unique role in transferring energy and heat. We've uncovered mysteries, like why the corona is hotter than the sun's surface. Though the sun is one among billions of stars, it holds a special place for us. Its unique characteristics, such as the internal processes of nuclear fusion, ensure the stability necessary for life. If a single photon of light takes up to 100,000 years to travel from the core to the surface, it means the sunlight you see today began its journey when humans were still living in prehistoric times. The sun's energy in just 1 second could meet Earth's energy needs for millions of years. What did you find most fascinating about the sun? Share your thoughts in the comments. Don't forget to subscribe to the channel and hit the notification bell to receive more amazing content about the world around us. The sun is so much more than just the star that lights our sky. It's the beating heart of our solar system, a living testament to the vastness and complexity of the universe that surrounds us.